Hi everyone, this is Swipro of Swift Programming. This is the fifth part of the subject, how to access shareable media files. The previous four tutorials covered how to read and write to shareable media files, how to request runtime permissions, and how to share files between apps. Today, we'll make a PhotoPicker app by using all of the previous methods. This app supports from Android 5 to 11. The PhotoPicker app interacts with the camera app to capture photo, saves the captured photo to the public storage, and loads the photo. Shall we take a look at the key function of each button? Pick photo. In order to use the camera app to capture photos, you need to share files between the two apps. Save to public. In order to save the captured photo to the public storage, you need to create a file on the public storage. Load from public. To load the photo from the public storage, use the photo's content URI. The easiest way to share files between apps is to pass the file object directly outside the app, but it's not possible due to strict mode API policy restrictions introduced in Android 7. The solution is to use the file provider class to wrap the file object as a content URI. To share a photo file between apps, you should send the content URI of the photo file and grant a temporary permission on the URI. To use the file provider class, you must first define a file provider. Let's define a file provider within the application tag in your manifest file. The file path.xml is a resource file. Inside the path tag, let's specify the directory to be used by the file provider class. For example, the path on the screen tells file provider that you intend to use the pictures subdirectory of your app-specific external directory. This path is the same as the value returned by the getExternalFilesDir function on the screen. It works successfully up to Android 10, but on 11, it will not work due to the changed package visibility restriction. Because of this restriction, your app cannot see or directly interact with most external packages without explicitly requesting allowance. To explicitly request allowance, you need to include the appropriate queries tag in your manifest file. For example, in this app, image_capture action is added. After the camera app is finished, use the Activity Result API to receive app result. The previously used onActivityResult function has been deprecated in Android 10, so you should use the ActivityResult API. This new API is a contract-based API newly introduced in Android Jetpack. If you register any contract using this API and launch the contract, Android automatically callbacks to your code when the contract occurred. To register a contract for receiving execution result of the camera app, you need to write the start activity for result contract using the register for activity result function. When the camera app is closed, it callbacks to your code according to the contract. For example, in this code, if the result is OK, then shows the captured photo file. If cancel, then deletes the file. To use Activity Result API, you need to add dependencies to Gradle file first. For the activity, add like this. For the fragment, add like this. Good job! The first button is done. Now it's time to save the captured photos to public storage. In other words, let's copy local files to public storage. The key is to create a file on the public storage. To do this, we will use the Media Store API. The easiest way to copy a file is to create a file object directly on the public storage. But due to the scoped storage restrictions introduced in Android 10, apps cannot save directly to the public storage. The solution is to use the Media Store API content resolver to create a file on the public storage. The save process is first make an empty image file on the public storage using insert function of the content resolver class. Let's call this file the target file. The result value of insert function is the content URI of the target file. Let's call it the target URI. The code for Android 10 and above is like this. The other Android versions is like this. And then save the picked photo file to the target file using target URI and IOStream. When reading a file stored in public storage, you can use the content URI of the file. The PhotoPicker app is tested on Android 5 to 11. This is a screenshot while running. This is a summary of the restrictions and solutions that have been explained for each Android version so far. This is a summary of some API deprecations and alternatives for the PhotoPicker app. The full source code is linked below the video. If you have any questions about this PhotoPicker app, please leave a comment. Thank you for watching.